function help us to understand the behavior of the function. They are not the graph of the function, not the graph, but rather they are the set of points where the function takes certain value. Set of points where f is equals to c. Let's take a very simple example. Suppose we have a function of the money we spend on purchasing something. So we have the unit price is equals to P, and the quantity purchased is equals to Q. For the sake of this example, we allow quantities to be fractions. Then, how much money do we spend? How much is spent? Well, the function that gives us the cost is given by f of pq equals price times quantity. Therefore, the level curve tells us how much we can buy with certain fixed amount. Level curve f of xy equals to c tells how much we can buy, or how many, but it doesn't matter, we can buy at a given price. For example, let's take c equals to 4. So assume this is like we have 4 euros. How many products we can buy with 4 euros? I'm sorry, here this should be PQ, but it's easy to understand. Nevertheless, let me correct it. So let's go back. How much we can buy for 4 euros? That depends, of course, on the price and the quantity. But for example, if the price is equals to 1 and we buy 4 units, we spend 4 euros. If the price is equals to 2 and we buy 2 units, we spend 2 euros. If the price were equals to 3 and the quantity is 4/3, remember I said we can use fractional quantities for this example, then here is a 4. Then f is also 4. So all these combinations of price and quantity are the level curves for this function at the level 4. Represented graphically, taking into account that prices and quantities are positive. This is a branch of a hyperbola. This is, for example, for f equals to 4. Lower here would be how much we can buy when f is equals to a smaller value, for example, 3.5. And above here is what we could buy with f equals 4.5. Treating only with functions of two variables. Nevertheless, there are many different examples of level curves. For example, the one given above, there are hyperbolas with the function f of xy equals to x times y. The level curves are x times y equals to c. Another type of level curves we find frequently are circles. Circles, for example, the function f of xy equals x squared plus y squared. So if x squared plus y squared is equals to c, this is assuming that c is non-negative. This is the circle of radius square root of c and center the point 0, 0. So the level curves of this will be when c is 0 will be just the center, and the bigger the c, the bigger the circle. Of course, circles don't need to be like that. It could be something like, for example, f of xy equals to x minus 1 squared plus y minus 2 squared. That's another circle. Even if we add here plus 10, this is a circle because the level curve is x minus 1 squared plus y minus 2 squared plus 10 equals to c, which simplifies to x minus 1 squared plus y minus 2 squared equals to c minus 10. So c minus 10 should be non-negative here, or c greater than or equal to 10. And there will be the circle of center 1, 2, and radius square root of c minus 10. Remember, we're assuming c is greater than 10, so this is a non-negative number. Does not need to be written in this very simple way. It could be expanded, and we could have the function f of xy equals to this polynomial of degree 2 equals to c. It is the same function, so it has the same level curves. Their standard type of level curves are ellipses. Ellipses are circles distorted. So it's not exactly like a circle, but will be longer in one direction than in another one. This is called the major axis, and this is the minor axis, though you don't need to know that. The formula for ellipses are like circles, but one of the factors has a number in front. Like for example, 2 times x minus 1 squared plus y minus 4 squared. This is an ellipse where the level curves are 2 times x minus 1 squared plus y minus 4 squared equals to c. How to decide in which direction the ellipse is bigger? So if we make x equals to 1, the first factor will be 0. So we'll have y minus 4 squared equals to constant. If we make the second factor equals to 4, then y minus 4 squared equals to 0, and we have x minus 1 squared equals constant over 2. So here you can see that the y takes values a little bit bigger than the x, and therefore this ellipse is distorted, being longer in the y direction than in the x direction. So the circle, the level curve, the function does not need to be given in this particular easy form that we have written here. It could be expanded like that, but nevertheless, level curves are the same. So don't worry so much about remembering every single thing, but just here, let me write the most common hyperbolas, which are of the form like this. Circles, which are obviously round ellipses, which are like distorted circles, and one that is easier, having said, lines. Lines are like that, where this is the x-axis and this is the y-axis. And that should be enough about level curves.